This is Junichi Horikawa, and I'm doing the live stream for the Houdini tutorial. It is the weekly tutorial sessions that I'm doing personally, and this is the 24th version of the tutorial, and the topic today is to create this kind of animated undulating scales inspired by a work of this artist called Funela Elms, which also looks like an scales, a shape of scales, waved scales on top of some animals or a lizard or something. And I found it really beautiful, and looks pretty simple to simulate it using Houdini, so that's what I'm going to teach you today. And I think this is going to be really simple today because you kind of can create this kind of flow wave using Houdini by choosing a right noise function. So that's the main topic today, and as you can see, the whole sketch is pretty short and you only have one vex code today. Yay. Right, so let's do this. Oh, thank you very much for the super chat game 3D. Oh, right, so let's do this. And the function that I'm going to use specifically today is a noise function, and there are many types of noise function in Houdini, but specifically what I'm going to choose today is this type called flow noise. Now there are similar types of noise close to this flow noise, like called as purling, but you have more control over, you have more parameter to control over the noise function when you use flow, especially if you want to animate the stuff. So this is what I'm going to use today. Using other method might be interesting, but yeah, for now, this one, flow noise. And you can check the types of noise by going to the unified noise bulb node page on the side effects documentation pages. So if you're interested, you can visit there to check. Alright, so let's start by creating a new node named as, oops, not here. First of all, let's create a geometry node, then start creating a null node having all the parameters that you want to use to control the procedural model. I'm gonna color this to blue. For now, I don't have any parameters yet. Okay, so first of all, let's create some geometry that you want to place the scales on. So let's say you want to place the scales on a sphere. Let's start by creating using a really primitive geometry. Oh, thank you very much for the super chat, Alexi Tartoring. Appreciate it. Right, so I have sphere, and since I'm going to put like dense scales on top of this geometry, it's better to have a really detailed dense vertices like this. So more vertices you have, better, more smoothed scales you look like when you put on tons of scales on top of it. And it's also better that you use remesh after this to kind of randomize the position of the vertex, because right now the position of the vertex is a bit too like constant or grid like. So it's going to look more artificial when you use this kind of grid. So to make it more natural, I'm going to use remesh to make the position of each vertices a bit more random. so use remesh, and let's control. So the number of vertices is equal to a number of scales, in this case, in the sketch that I'm going to create today. So it's better that you could control the density of the remesh, which is controlled here. So let's have this as a parameter first. Okay, this target size. Right, so let's go to the null controller, have a parameter, float parameter, and let's name this target scale, target how do I name this? Edge length. Or other way you could do is to use a scatter points on top of a geometry. That should also work. In that case, you can control the number of points. So in some cases that might be better, like this. Maybe this is better, but I'm going to go with this one. So because you can kind of control the density even if you put any different geometries right here instead of sphere. So I'm gonna go with this target size for the mesh. So for the edge lengths that I have created, let's copy this parameter and paste it right here. Now the range seems a bit too big, so let's set the range of this edge length from 0 to 1. Right, and keeping it 0.1. Wow, this looks a bit too constant, too grid. Let's scale this sphere itself a bit bigger, like 2 times, so that you have more points to test out. All right, looks good. Now, so here is the part that is the where you only going to use the effects today, and that's where you're going to create kind of a flow, the flow vector, the vector field for the scales to place, and that's the only place where you're going to use vex today. All right, so I'm going to use a point wrangle. I'm going to name this wave for scale. All right, so before get it into writing a code, let's go to the vex function page for Houdini and search for a noise function that I want to use today, which was there are many types of noise, but the one that I'm going to use is this flow noise. So either generate 1D and 3D prilling flow noise from 3D and 4D data, or flow P noise there. Okay, this looks a bit more simple, so I'm going to use this flow noise. Okay, so what you're going to input as a parameter for this function is two things. One is a vector or float value, vector or xy value, which is similar to the prilling noise, and additional parameters you want to input is flow. And I think there should be an explanation what this flow is about. Okay, so flow noise feels very similar to prilling noise, but with an extra flow parameter. The flow parameter can be thought of as an extra dimension, but a dimension whose period is always 1. So this means is that this flow value is periodic. So when you type 0 and when you type 1, you get the same result. So that's where you can use it to create like a loop animation. So when you put the flow value to 0 on frame 1, and when you put the flow value to 1 when the frame is at the end frame, then you can kind of create a looped animation from the end frame to the start frame. Does it make sense? Let's try this out. Alright, so let's bring this up and let's actually write a code which uses the flow noise. Okay, I'm going to create a single noise value. I'm going to name this noise val and use flow noise function. Let's try to use a point position as a seed for the noise and extra parameter called flow for a second parameter. And this flow value, this flow value should be in between 0 and 1. Okay. Let's promote this channel, this flow parameter for the point wrangle right here. Okay. And let's see the actual output, how this noise value look like. And I have written as float, but actually I want to output as vector because I want to kind of get the direction where the scales should face. So right like this, and let's get the actual directional value. But before doing that, the vector noise val, when you use the flow noise, the range of this noise value is in between 0 to 1. But actually when you want to create a kind of a random vector direction which goes from -1 to 1, you kind of have to fit or remap this value from 0, 1 to -1 to 1. So to do that, I am going to use a fit value. So first of all, I'm going to fit this noise val, which is in between 0 to... I'm writing like this because you have 3 elements for this noise val, because this is vector, which is x, y, and z. So for each x, y, and z, I'm going to refit using this fit function. And from 0, 0, 0 to 1, 1, 1, I am going to set the new range from -1, -1, -1 for x, y, z, and 1, 1, 1 for target maximum. As a result, you should be able to get the vector which faces 0 to 360 degrees in 3D space. So it's going to be a really random direction. Could be a random direction, but by using a flow noise, the direction which is close to each point should have a kind of a close direction. So now I have this vector. Let's check this out by visualizing it, how it looks like. So I am going to update the noise, the normal direction with this noise val, just to check for now. Alright. And let's turn on this point normal. And let's also give a bit of length to this normal direction by, I think there are some parameters you can control the length of normal. Yeah, this one. Let's set it to 1. Scale normal. Okay, so you already see that you kind of can see the flow on top of this geometry created from the each vertices from the this geometry. It's going inside as well. And let's also try out the flow parameter, this one. If I change this from 0 to 1, you can kind of see the animated flow direction. Now if I change this value procedurally by using the frame value, like from 1 to 240, this for that you have right here on bottom, and convert this frame value from 0 to 1, then by playing this sketch you can kind of create a looped animation just by changing this flow value based on the frame. So let's set the frame to really low value, end frame to really low value, because I want to check the loop. And you can change the frame value to from 0 to 60, from 1 to 62, 0 to 1 by just dividing the current frame value, which is expressed by this expression, divided by f, and which is equal to 60, this one, $f_end. So when the frame is at 1, it's really close to 0. If it's close to 60, then it's equal to 1. So as a result, if you play it, the flow value will change based on the frame. And as you can see, going from step 60, frame 60 to step frame 1 gives no jagging or jaggling. It just smoothly connects from frame end to first end. Right, looks good. Now the problem right now that I have is that, as you can see, each vector, each directional vector that you have right now created from the flow noise have different lengths, and also some of the vectors are facing outward from the vertex, and some of the vectors are facing inward, going inward like this. But actually, in order to place the scales in clean manner, you want to have this initial flow vectors lay on top of the surface, meaning all those I want all those vectors having a direction which is equal to the tangent of this surface. So let's do that. Right, to do that, the simple way you could do is to calculate the cross vector between this newly created flow noise directional vector plus the normal vector, the original normal vector, which is this one. By calculating the cross vectors, what you could have is a perpendicular vector of those two vectors. Let me explain in sketch. Okay, so by having two vectors, when you calculate the cross vectors, you can get the perpendicular vector of these two vectors, which means when these two vectors are placed on a plane like this, then the cross vectors of these two vectors is always perpendicular to this plane. So that's when you can use cross. So it's written like this. pretty simple, but it's really useful, obviously. So let's try to calculate that. And first of all, and before doing that, I also want to set the size of this noise value, which I've created, to equal to 1, or normalize it so that you don't have well, it's you have a clear when you use the cross vector cross product between two vectors, you always have a vector which its length is equal to 1. So first of all, let's normalize this to make the length of the flow vector to 1. Then calculate the cross vector using cross product between the normal vectors and the value that you have created right here. Okay, and let's replace this normal with this cross vector to see how it looks like. Alright, and now the length looks too strong. Let's give this back to 0.2. Alright, now all the vectors are lying on top of the surface. Looks clean. Nothing goes outward or inward. It's always laying on top of the surface, meaning laying on top of the direction is a tangent vector as off the surface. Looks good. And if I play the animation, looks good as well. Right. Now I want to use this vectors in order to place the scales, such as using a copy 2-point node. But in order to do that, I want to have additional vector information, because by having just one vectors, the orientation is, when you do the orientation using the vector, is not enough. You have to have at least 2 vectors in order to orient the object in a specific direction. So, and that additional vector could be perpendicular to this vector that you have created, and that could be equal to the normal vector that we had previously. So actually, we could keep this normal vector as it is and use this cross vector that I have created as a different name. And there are some preserved vector names in Houdini that you can use it for a orientation, like point, or copy 2-point, or copy sop node, and that is up vector. So let's update the up vector using this cross vector. Okay, so now you have a normal vector, and you also have an additional vector called up. When you look at the geometry spreadsheet on point attribute, there's an attribute called up right here. Let's also visualize this to see how it looks like by adding a marker. Name this up, up, up. That's a vector. And let's set the scale to 0.2 as well. Alright, looks good. Now the normal stays always the same. It's always perpendicular to the vertex surface. And the yellow one is the one that we have created using a cross vector, cross product. Right. Let's make sure that the length of cross product is always equal to 1 by using a normalize again, since some of the vectors seems to have less length. Okay, I think that's good. Looks good. Okay, now at this point I can try out by placing scales using those two vector information. So let's create a base for the scale. I'm just going to use the circle, but you can replace this geometry by using any custom stuff, like could be squares, could be a bit more complex geometry. But for now, I'm going to try it out with a really simple geometry like circle. Right? Did I say sphere? I mean circle. Right. And let's set the size of this scale, single scale, to 0.1 for radius. You can control that based on the parameters you have set it here. Maybe you can just copy this edge length and paste it to this uniform scales for this scale. Right, and let's also set the division to make it a bit more look like a circle, maybe 16. If you make it too much detail, the operation is going to be a bit slow, so let's try this out without making this too big for now. Alright, and also I would like to make it a thickness to this scale, so let's give a extrusion with some value, like really small value, like 0.035 or something. Right, and you also want to cap this hole by checking this output back. Looks good. Now let's try this. Try the copy subnode or copy to point node to place this geometry on top of using this vector values. Okay, so copy 2 points. Right, now as you can see, we have some problems here because it's laying really flat this way. So I might need to change the basic plane where this circle lies. Currently this circle is lying on XY plane. If I change it to YZ plane, it looks a bit better. Let's hide the edge. Okay. It looks a bit more like a scale. If I change this to XZ plane, pretty much the same. Right. But actually I would like to start with a XY plane and try to control the angle by creating an additional function on this vex wrangle, which is by rotating one of the vectors that we have here, either the normal or the cross vector that we have created here. Okay. So let's do that. Okay, so we have, maybe what I could do is to change the angle of the normal vector, I think. If I go back to the code here, geometry here, and if I check the direction for each up vectors and normal vectors, like this. And currently, if you look at this sketch, okay, so you have a sphere, you have this up vectors and normal vector like this. And currently the circle is lying like this. Like this. So, but when you want to rotate this circle, just by using those two vectors, what you could do is to change one of the angles, one of the vectors' angle. In this case, by changing the normal vector, I think should work because it is determining the normal direction of this circle as well, circle geometry, the scale geometry as well. So when you rotate this normal like something like this, then this disk should also rotate corresponding to the rotation of this normal direction, the rotated normal direction. So that's what I would like to try out, rotating this normal direction by using some angle, customly created angle parameter. I think you should be able to rotate the scale itself as well on top of the surface. Now I kind of want to create another noise values in order to control the angle, but I can try this out by using a constant value for now, for a starter. Right, so to do that, after I have created the up vectors, what I could do is to have an angle value named as ang, and let's have this as constant value, like say radians 30 degrees. So I want to rotate the normal vector by 30 degrees. And I think in this case counterclockwise probably. And let's use the rotate function in order to rotate the vector. So first of all, I need to have the rotational matrix. So let's create the matrix called identity matrix using ident, not indent, ident, and rotate that matrix by this angle that I have created here. And you also have to provide the rotational axis, and this rotational axis in this case is actually equal to this up vectors right here. So using this up vectors and axis, you can kind of rotate this normal based on this axis. Right. So use up vector. Okay, now I have created the rotational matrix. What I could do to rotate the normal vector is just multiply this by a matrix like this. Now as you can see, something just happened. The normal vector all the normal vectors have been rotated 30 degrees. And by using this, the scale, the final output using this two vectors, you should be able to have all the scales being rotated 30 degrees as well based on the normal direction like this. So if you make it to 45, all the scales will be rotated 45 degrees. And this itself is already pretty interesting, but to make it a bit more interesting, you can also control this angle using additional flow noise parameter. So let's do that. Okay, so instead of having a constant value right here, let's use a flow noise, and that additional flow noise using at p as a parameter, a first parameter and use the flow parameter, which is equal to this one, right? And at this point, the angle is in between 0 to 1 because I'm using the flow noise. So to make it a range for the angle, I'm going to use a fit from 0. Currently the noise range is in between 0 to 1, but let's convert it into -1 to 1. Then multiply this by some additional parameter that you want to control outside, named as max angle something. Right, and maybe I could use the radians so that the input that you're going to use is degree, this one, max angle. So in order to make it a degree, I can set the range for this max angle from 0 to 360 degrees. And let's try this out by changing this value. As you can see, making this value larger. Some of the plates have really large angle, rotated angle. Some of the plates have really flat rotated angle. This makes this whole scales outlook a bit more interesting than before by using a constant value. Right now, most of the stuff that I want to show is done, but in order to control a bit more of this flow value, such as the density of this flow, make more whole flow of this vector noise a bit more smooth, or if you want to make this density of this flow noise a bit more dense, then what you could do is to have additional parameters to the current setup right here. Such first thing I could think of is to add a scale value for this at P, because this flow noise is based on the point position. The closer the point position is, it's going to be a bit more smooth. The value that you're going to get by using the flow noise is going to be really smooth when the point is really close. When the point is really far, then the value in between the points will have a bit more different values, a bit more far values. So as a result, you'll get more really rough noise, or really turbulence, or rough, how do I explain it? More dense. Well, let me just explain by showing it. Okay, so let's have additional parameters for the point. Let's name this scale. And currently, if I set it to 1, that is equal to having a point itself. But if I make this 0.5 as a scale, you kind of can see that the noise, the flowness of this whole geometry become a bit more smoother. Make it really low, really low. It's going to be really smooth. But in order to make it looks more a bit smoother, I might want to use the same value for the angle as well, right here. Okay, now it looks more smooth. Maybe too smooth. Alright. If you increase the value more than 1, you could have more randomized, a bit more randomized value like this, but still looped. Okay, looks good. Now, this is pretty much it, but as additional setup I could show you is if you want to have if you want to have a noise like flow really smooth like this, but when you get closer, when you have a bit more randomization on a detail, even though you want to have a big gestures like this, what you could do is to have additional noise flow, flow noise, addition to this one, and having two noise value and add it together. One of the noise could be really have a really low scale. One of the noise could have a big scale, which creates this really randomized value. But by setting a ratio in between the really dense noise like this and really smooth noise like this, by setting the ratio of this one bigger than the dense one, then when you add those two values together, you should be able to create a big gestures like this, but in detail you have some kind of a bit more jittered rotation or jittered normals flows. Let me just show you how to do that. What you need to do is just copy this same stuff right here, maybe from this 3 lines on the third. On the code, you can just copy this, copy paste this, and name this by adding number 2 to all those variables, and same for the parameter scale 2. And also maybe you can keep this flow as it is, because it's always you want to use this for the timeline, and the timeline shouldn't differ to when you use the same flow noise. So you just want to have this scale 2 parameter as additional value, and after having two noise value, you want to add those together, and let's name this final val. The simple way you could think of is to add those value like this, but this just mix those two value 50% to 50%, but to make one of the noise value bigger than the others, you can multiply this value by having additional parameter called ratio, and multiply the other value by the same ratio, but in this case 1 minus ratio, so the ratio should be in between 0 to 1. So when the ratio is equal to 0, the noise value 1 is not going to be used, but all the values is coming from noise 2. When the ratio is 0.5, then 50% and 50% is used. If it's 0.8, then 80% of noise value, the first value, will be used. 20% of noise 2 value will be used, something like that. And after adding those two noise value together, I'm going to normalize this so that the length will be equal to 1 again. Right. Okay, I have an error here. Yeah, like this. Okay, and I need to use this final value somewhere, which is right here, I think. Right. Instead of the noise value. Okay, and let's promote those ratio value and scale 2 value. Okay, let's change the scale 2 to some value here. Okay, do I see any change? Don't think so. Let's see what. Okay. So when I change the value, okay, I don't see any changes. Let's see what's wrong here. So final value, okay, noise value. I'm using ratio here. Okay, I have scale. Oh, okay, I need to change this one as well. Right. Okay. Oh, thank you for the super chat, KT Ma. Thank you very much. Okay, now I should be able to change. Use this ratio and scale to mix the two noise value right here. So let's check this out using a static image like this. First of all, let's set the ratio to 1 so that the vector is the flow is used only using this scale 1. This one. Okay, where was I? So I have made this to noise value, I think, and I have set the ratio value in order to control the ratio between the noise 1 and noise 2, and how much you want to mix those two values together. And currently I have set the ratio to 1 so that only the noise 1 value is used. Alright, and in order to use the noise 2 value, you can decrease this ratio value like 0.8. Oops, I see some glitches on the screen. Hopefully it's still working. Oop. Wow. Hopefully it's still working. Yeah, I hit this kind of glitch. What is happening right now? Well, let me just keep going. Hopefully it won't crash. Okay, now if I decrease the ratio, I can kind of add additional scale value, which is this one right here. To make it a bit more visible for scale 2, I have to increase this value, the range of this scale 2. So let's go to the edit parameter and set the range from 0 to 10. Maybe for scale 1 as well. And if I as I said, if I increase the scale for this flow noise, you can kind of have more dense, bit more jittered noise. So if you increase it, you can kind of see the difference when it's equal to 0 and when it's having more values like this. You have more. Okay, I think it's because I have disconnected the display. Let me just save this and reopen this file so that I should be able to have no glitches. Okay, let's save this as undulating scales. Let me quit this and open up the file again. Wow, I still have it. Maybe I need to restart, but let me just continue with this glitchy display. Right, and where was I? So I was controlling the value here, so scale 2. So as you can see, when I increase the scale 2 value, the detail of the noise, the flow, become a bit more jittered, but as a overall big gestures, it's using the scale 1 more of a scale 1 value, a noise 1 value, because of this ratio. But if I flip it from 0.7 to 0.2, but so that it's going to use scale 2 more, then you have more jittered noise like this. So less smooth noise is used, but more jitter noise is used in this case when you flip the ratio like this. So let's keep this to 0.8 or something, and having this scale 2 really high, but only 20% or of the noise 2 is used like this. And as a result, you should be able to have a bit more natural noise, natural noise flow. Okay, now as a final step, I want to colorize each scales based on the normal direction or the up direction. Either way is fine. So let me do that by, say, let's use the normal direction. Okay, so this is the final normal direction for this geometry. I could also update the color node, the color attribute called CD, by using a normal, but as you might have guessed, the normal direction have a range between -1 to 1, so I need to refit this color, a normal value, from -1 to 1 to 0 to 1. So it's going to be the same step as I did for the flow noise right here. But in this case, the source range is in between -1 to 1, and the color value is actually between 0 to 1, so I need to do like this. Right, so this is the colorized. I'm just using the normal value as a color itself, and as a result making a bit interesting gradational skin-like scale pattern. Okay, I really hate this kind of glitch. Okay, now it's time to bring all those parameters that I have set it here to the null controller so that I can control it. I can control all those parameters in one place. Okay, bring up the edit parameter interface for the null controller and check off this 4-bit linking parameters from outside the subnet. Then just drag and drop all those parameters that you have set like this. That's everything, I think. Apply, accept, and let's play this out and change those values to see the difference. If I increase the angle, you can kind of see the differentiation of angles. If you change the overall scale, you can control the overall smoothness. This is the additional noise 2 in order to add the detail to the overall noise. And this is the ratio, how much you want to add the additional normal, additional noise value to make it makes it look more natural. Alright. Okay, so glitchy. Okay. So that's pretty much it for today. You can use the same method for other type of geometry like torus. Let's scale this up. Let's also set the division a bit more higher to make it more smoother. Looks like scales of snakes. Looks interesting. You could also use this sample geometry, test geometry like peg head. Which is also looks interesting. To make it more dense, you can control the edge length as well, like make it 0.05, you have more scales. Yeah. Maybe you want to add the extrusional distance as a parameter as well, or maybe you can copy this parameter and make an expression for this one, multiply by 0.035 or something. That might be too thin. Yeah, that might be better. Okay, so that's pretty much it. This was pretty simple, but I guess I speak too much, even though with this kind of simple setup. But by using this simple setup, you can kind of create this interesting flow and use it for any kind of purposes. In this case, I used it in order to place the scale pattern, but could be used for any kind of different kind of purposes. Right, so since my display is glitchy right now, I would like to end right here. Let me know if you have any questions. I would like to answer it. If not, I would like to end it here. And for this file, you can download the file from the video description. A setup is a bit different than the one that I have just created here, so I'm going to upload this one as well as a live version. But if you go to the video description page, video page of this YouTube video, you can download the HIP file from the GitHub page. So if you have found this interesting, then please try to check that out. Okay, thank you very much for watching the live stream, and I am sorry for the trouble that I had today. I'll try to prevent that for the future live stream, but I am not sure what the reason was. And for the archive, I'm going to edit. I'm going to cut where I have crashed, so that the other people who watch this won't notice this. Right. Okay. Any questions? I am really not sure why this glitch is showing. Ooh. Okay, well, I guess no questions, so I would like to end right here. Thank you very much, and hopefully I'll see you all next week as well on live. Yeah. Okay, good night. Yeah, I had a comment: in more complex setup, you can prevent intersection. Yeah, yeah, you're right. If you make it more complex, if you have more conditions, you should be able to prevent this kind of intersection as well. All right, thank you. Good night. And let me end right